Predicate logic is also called first order logic, and predicate logic is another way of representing the knowledge into the agent, which is your logical agent or the knowledge based agent. We can represent the knowledge with the help of predicate logic, which is also called first order logic. Now, what is that? The predicate logic assume the word contains facts. This first order logic is like natural language. Assume the word contains what it contains. It contains in the form of objects. So because every sentence has some sort of objects, so it will assume that there is some objects, and the objects could be people, houses, numbers, color, baseball game, wars, anything can be taken as an object. And the second thing is relation. Relation could be like the ball is looking red, or ball is round, or this people is the brother of this people in that way. This people is bigger than that. This house is a part of this house, and this room is a part of this house. Comes between these type of relations are there. And the last one is function relations. Function relation means the father of, in that way, best friend, one more than, plus, and these are the function relations. So in the predicate logic, these three are the different entities that will come, and with these we can represent any natural sentences or natural language sentences. Let's see some example so that you could understand very easily. It is saying that Stephen was intelligent. So how you can say that Stephen is intelligent? In that you have to find out two things. The first thing is the subject, sorry, the object which you have, the object and the relation between them, or the relation function relation if it is there. So in this particular example, you will find out the object, which is Stephen, which is taken as a subject in this particular natural language. We say it is a subject, right? Was intelligent. So intelligent is nothing but the attribute of this particular subject. So intelligent is the attribute or the property or characteristic. It is also called predicate. So you can see that there is subject, which is also called object in the sense of predicate logic, and here we have the attribute or the property of this particular subject, the property of this particular subject. Now, how you can represent in the form of predicate logic or the first order logic? You can do that with the help of this, that you have to write predicate first and the subject after that. So what is the predicate? Predicate is intelligent, or the attribute is intelligent. Who is intelligent? Stephen is intelligent. Okay. So let's see this. How you can represent in the first order logic? It says that you have a predicate. Predicate means its property. The property is what? Intelligent. Who is intelligent? So Stephen is intelligent. In that way you have to write. So this is your object, and this is your relation of with that particular object. Is also called predicate. Now the second sentence is Amir and Shahrukh are rivals. So how you can write in the predicate logic? You can write like, what is the property here? The rival are the property. That is your predicate. Predicate you have to write here, and in bracket you have to write the subject. So what subject you have? You have Amir and Shahrukh. In that way I can say that Amir is rivals to Shahrukh, or Shahrukh is rivals to Amir. In that way you can say the sentences. Or Amir and Shahrukh are rivals to each other. In that way you can say that. So this is how we can represent in the predicate logic. Let's see some more examples so that you can understand it. The next example is Richard's father is married to John's mother. So here if you'll see, what are the different predicate we have. We have John's mother is one predicate, mother is one predicate, then father is another predicate, and the married is another predicate. So we have three predicate. What are the subjects we have, or what are the object we have? So John is one object and Richard is one object. So if you can just simplify it, so John's mother, how you can write John's mother? You can write mother and in bracket you can write John. So you can say that John's mother. Now, Richard's father, how you can write down? You can write down the predicate first, which is a father, and the subject here in the Richard. So this will be your like Richard's father and John's mother we have written in this form. Now the next predicate is married. So married means who is married? So these two are married to each other. So we'll write the predicate here, married. Father of Richard's father and John's mother are married to each other. In that way, we can write it down. So this is how we can write it down with the help of the predicate logic. So this is how we can write in the form of predicate logic. So I think you understand we have to find out the predicate first. Predicate is nothing but the attribute, the property or the characteristics of the subject. And inside that we have to write the subjects. Okay. Now the next one are the syntax of first order logic, basic elements. What are the basic element? We have some constant in the basic element. We can write some constant. If we know the name of the subject, we can write down that. So that will become the constant. Variables, we can, if we don't know the subject name, so or we don't know the actual value of the subject, so we can write out in the form of variables. Then we have predicate. Predicate is nothing but the relation between those subject, that is brother or greater than or equal to. Then function relation, like square root or left leg of, in that way. The connectivity, we know all this connectivity, that is from the propositional logic. Equality, or the last one is quantifier. So we can understand all those things. We have to know what is that quantifier is. So we have two type of quantifier here. About that we'll see later on. Let's understand some more examples. So some atomic sentences are like this. An atomic sentences is formed from the predicate symbol followed by the parenthesis list in terms of, like, Raj and John are brother. So how you can write out then? The predicate is brother. So predicate will come here. Predicate will come here. Then we have Raj and John. Those two are subject. Subject are, we are writing inside the bracket. We have, if we have this predicate, so we'll write the predicate and we'll write the terms in that way, right? That we have just written. Where they, or we can write down term 1 or equal to term 2. In that way also we can write down. Term is nothing but the function of term 1, term 2, or the constant or the variable. So these term could be either constant. Constant means some name or something, or this term could be a variable, right? A variable. So the constant complex sentences. So complex sentences we can write down with the help of some operations, some connectivity operations like negation. We have this conjunction. We have some disjunction, means and or. We have implication and by implication. In that way we can write down some complex sentences like this. That sibling means John and Raj are sibling because they are brothers. So we can write out that, like, John and Raj are siblings. That implies that Raj and John are sibling. It means that John is sibling to Raj, or we can say that Raj is sibling to John. In that way I can write it down with the implication symbol. Okay, let's go to the quantifier. Quantifier means, which I have just told you about this. This is called quantifier. So we have two type of quantifier here. One is called universal quantifier. So the universal quantifier could be represented as this symbol. This symbol is for universal quantifier. And how we can write down universal quantifier, variables and sentences. In that way, we can write it down, so any sentences. So for example, every cat drinks milk. Okay. So let's assume that we have three uh, number of cat in the world. Let's say we have 3 cats in the world. Okay. So it is called universal of this is the universe. So in this particular universe, we have, let's assume that we have 3 cats. So how you can write it down? You can write it down for one cat, like x1 drink milk, means maybe x1 is the cat which drinks milk, x2 is also a cat who drinks milk, and x3 is also a cat who drinks milk. So when we do AND operation, means it is applied for all. So how we can write down in the form of universal quantifier? So we can write out that like this, like universal quantifier and the variable, right? Universal quantifier and the variable is your x. Yeah, universal quantifier, and it is saying x. And then you can write down what is x. X is nothing but a cat. So you can write down x is a cat. So cat is what? A predicate, you can say, for that particular variable. It is showing the characteristics of the variable. Means x is what? X is a cat. And which implies that x drink milk. So that in that way you have to what? You have to read this particular sentence like x drink milk. And what is x? X is a cat. So for every x is a cat, x drink milk. In that way you have to represent. So we can say that every cat drinks milk. So that could be represented by this universal quantifier in first order logic. So this is how you can represent. Let's see some more examples here for with the universal quantifier. So the first example is everyone at integral is smart. So if we have everyone type of thing or all type of thing in the sentences, so we'll use universal quantifier. Okay. Let's talk about this. Everyone at integral is smart. So we'll write down everyone. How you can write down? For all x at integral, then x is smart. X at integral, then x is smart, right? So you can write out then if x at integral, then x is smart. In the same way, which we can write down here, for all x, if x is a cat, then x drink milk. So this also we can say that for all x, if x at integral, then x is smart. Okay. Let's see this example. All kings are persons. So how you can write down? For all x is a king. For all x, x, if x is a king, then x is a person. So for all x, if x is a king, then x is a person. Okay. So in that way, we can write down the first order logic with the help of universal quantifier if we'll get these type of sentences. Let's see the another type of quantifier, which is called existential quantifier. Okay, existential quantifier could be represented with this symbol, which is mirror image of E. So existential quantifier, here also we have the variable and the sentences side by side. So, but here we doesn't have all entities. We have these type of examples, like some cats are duffer, right? So we have written here some cats are duffer. So we have some cats in the universe of disclose, means we have x1, x2 and x3. So how we can say that x1 is duffer, x2 is duffer and x3 is duffer? We are not saying all cats are. We are saying some of the cat. So that's why it is written in a disjunctive. It means it is written in a or. How you can represent it? You can represent it some x. If x is a cat, then this x is a duffer. So in that way we can write it. For some x, x is a cat and x is a duffer. Getting it? So this is how we can write it down. For some x, x is a cat and x is a duffer. Now let's see some more examples here. The example is some prime number is even. So how you can write down some x if x is a prime and x is a even. Some student like bunk. So we can say some x is a student, then x like bunk, right? So in that way we can write it down with the help of existential quantifier. Existential quantifier is what? Is a representation in first order logic. So for someone, in that way we have to use existential. For all or every, then we have to use universal quantifier. So we have two type of quantifier, existential quantifier and universal quantifier. So there are some mistakes that we generally do. What we do is, if you remember, for the universal quantifier, we use implication symbol. And for the existential quantifier, we use this conjunction. So this is the conjunction that we are using, conjunctive way of representation in here. But for here, we'll use implication. So always you remember that for the universal quantifier, we always use implication. And for the existential quantifier, we always use conjunctive. Conjunctive means and operation, or the conjunction we'll use. And for universal quantifier, we always use implication. These are some property of these quantifiers. So what are the property we have? We have the property like for all x, for all y, it is same as for all y, for all x. Okay. For this existential quantifier, we can write it down. Some x, some y is same as some y, some x. Now, if I am writing like some x, all y, it is not same as all y, some x. So this is not equal to these two. Now here, some x, some y, love x comma y. What is the interpretation of it? Some x, all y. It means that there is a person who loves everyone in the world. Now, if I'm just making opposite of it, means all y, some x, love x comma y. It means that everyone in the world is loved by at least one person. So for both the first order logic, we have different meaning. So the meaning is different for both the things. So that's why these two are not the same. Now, there is a property called quantifier duality. It means that one quantifier could be represented with another quantifier. So it is written that for all x, x like ice cream. Okay. And here the same thing could be represented by this. It says that not some x, not some x. Some x doesn't like ice cream. Okay. Some x like, for some x, x like broccoli. Here it says that not all x, x doesn't like broccoli, right? So you can see that this and this both will produce the same meaning, and this both will produce the same meaning. So that property is called quantifier duality. Let's see some more examples related to these quantifiers. So some examples are, all students are smart. So how you can represent it? For all x, if x is student, then x is smart. All graduate are unemployed. How you can write it down? For all x, if x is a graduate, then x is unemployed. Let's talk about the existential quantifier. Someone is crying. So how you can write down? There is some x, and this x is crying. Virat love Anushka. How you can write it down in the first order logic? That Virat and Anushka loves each other, right? So how you can write that down? Loves Virat, comma Anushka. Everyone like everyone. How you can write it down? So that is your way how you can write it down. Now let's talk about there is some inference technique for logical agent. So we know what is logical agent is. A logical agent is nothing but it is a knowledge based agent in which we have some knowledge, and this knowledge will be upgraded based on some inference system, and this inference system are nothing but different inference technique in the logical agent. For that particular inference technique in the first order logic, we can actually represent it, and we have actually three type of inference technique by which we can represent in the logical agent. So the first technique is called forward chaining, second is called backward chaining, and the last one is proof of resolution. Okay. Now let's understand what are those inference techniques in first order logic. So the first inference technique is called forward chaining. So what is forward chaining? So forward chaining matches the set of conditions and infer results from these conditions. Infer results from these conditions. For example, if it says that A is true and all these things are there, let's say here what it is saying that forward chaining matches the set of conditions, it matches the set of condition and infer result from these conditions. It means that if there is some condition given, so from the condition that is given, it will find out the results or the conclusion. Okay. So let's see, there are some condition that is given. The first condition is A is true. So if we find out that A is true, and we have some conditions given, so these are all conditions, like B implies C, A implies B, and C implies D. So these are all different conditions in the form of propositional logic has been given. What we have to prove? We have to prove that D is true. So nowhere it is written like D is true. It is only written that A is true. Okay. Now we'll start, because we are using forward chaining, we'll start from the very beginning. So we'll first find out that A. We find out that A is true. We find out that A is true from this particular statement. So we can conclude that with this A implies B, we can conclude that B is also true. How you can conclude B is also true? We can conclude B is also true based on this particular propositional logic. Now the next one is B is true, then C is also true. How? if we concluded that B is true, then if B is true, then C is also true with this particular propositional logic, which is B implies C. Now we concluded that C is true, then D is true. How we can find out D is true? Because from this condition it says that C implies D. It means if C is true, and then D is also true with this, and then we prove it that D is also true. So this is the proof that we have to draw. So that conclusion has to be find it out from that system, and that conclusion is nothing but any action to the logical agent, right? So how you will draw the conclusion? You will draw the conclusion with these three techniques. So the first technique is forward chaining, second technique is backward chaining, and the last one is proof of resolution. So we have three techniques by which we can find it out that what should be the conclusion. Okay. Now let's go to the second technique, which is called backward chaining. So in the forward chaining, we have started from the very beginning, and in the backward chaining, we'll start with the back. It means that we have started in forward chaining with this particular statement. Now we'll start the backward chaining with this statement. So it is a backward search from goal to the condition used to get the goal. So this is your goal, right? You have to prove that D is also true. So we'll start with that, starting with D, and we'll assume that D is true. So if we'll assume that D is true, then we'll find it out C is also true. Why? Because C implies D. So if we'll find D is true, definitely C will also be true. Now if we'll see C is true, then definitely B is also be true. If we'll find B is true, then definitely A is also be true. And definitely A is true here. In this particular example, A is true written here. So in that way, we can prove that D is also true. So this is how your backward chaining works. It is just an opposite of forward chaining. Now come to the last one. Last one is proof of resolution. Before going to the proof of resolution, let's understand the resolution inference rule. What is the resolution inference rule? Let's go to the inference rule and see what is the resolution rule in the inference rule. So if you'll come here, where is the resolution? You can see the last one is the resolution rule. The last one is the resolution rule. Okay. This one is the resolution rule. It says that if you are getting A or B, or you are getting negation of B or C, so what is the conclusion? Conclusion is A or C. It means that this B and the negation of B will be cancelled out. You will get A or C. A or C. Or A conjunction C, right? Because this symbol is called conjunction, right? It is called, sorry. Yeah, this symbol is called disjunction. Which one? Your OR operation is called disjunction. OR operation is called disjunction, and AND operation is called conjunction. So it is also called disjunction. So in the inference rule, if you have this disjunctive form, if it is given, then this B and the negation of B will be cancelled out, and you will get A and C, which is left out with the disjunction or with the OR operation. Okay, this is your resolution. Now in the inference rule that we have to go, inference technique, in the proof of resolution, let's see the proof of resolution, what it says. The resolution rule is in propositional logic is a single valid inference rule that produces a new clause implies by two clauses containing complementary literal. If we have complementary literals, So from that rule, it will find it out. So it is a disjunctive rule. If we are getting disjunctive rule with the complementive literal, you will get another rule. That's why it is saying another clause, you can say. So this is one clause, this is another clause with some complementary literals. So you will get another clause. A literal is a propositional variable or the negation of propositional variable. So you have this propositional variable, um, this variable and the negation of it. So you'll get this another clause. This is your resolution. And this last one, that is proof by resolution, we can also conclude some conclusion afterwards. So we have three techniques by which we can find it out the conclusion, and these three techniques we'll use later on in this particular examples. So what we do is, now we'll see some of the examples related to these inference rule, and this is the first example that we are going to see.